Good morning, everyone. Last week, we have started to discuss the addition of vectors. In that case, we have discussed about the principle of vector addition, and we did one application, that is vectors in same direction. How to add vectors in same direction. Okay. In that case, okay. Shall we recall our previous knowledge? Okay. So far up to now, we have discussed what is a vector, definition of a vector, then the differences between vector and scalar quantities. Then we have discussed about some terms in vectors, especially the modulus of vector. What is the modulus of vector? That is the magnitude. Then we have discussed about some special vectors. Some of those are null vectors, then negative vector, unique vector. Those kind of things were discussed. Then after that, we did how to equalize, or how to choose equal vectors among the vector system. Then how to choose a negative vector from a vector system. After that, we have did some calculations. We have done some calculations. Suppose we are given a vector system and we are asked to find the magnitude of a particular vector using the magnitude of other vectors. That kind of calculations we did in our previous classes. Then we have moved to mathematical operations of vectors. Under that section, we are going to discuss about addition, subtraction, especially addition and subtraction. Okay. Under this section, we have discussed principle of vector addition. Principle of vector addition. Suppose we are given two vectors. According to principle of addition, what are the steps that we should follow? What are the steps? What is the first step? Tell me. According to the principle of addition, what should I do? What is my first step? Yes. We should coincide B and C. B means the end point of the first vector should be coincide with the starting point of the second vector. That is my first step. So I have to coincide B and C. Then there will be two free ends. One is a starting point, other one is a end point. So I can construct a vector by connecting these 2 points. My second step is construct the additional vector, or construct the new vector by connecting this starting point and the end point. This is a starting point, this is end point. So according to the principle of vector addition, this vector gives the addition of these two vectors. This is the principle. After this principle, we have discussed one application, that is addition of vectors in same direction. Okay. In that case, if I add two vectors in same direction, what is the magnitude? Magnitude is equal to the addition of two magnitudes of two vectors. Okay. That means, suppose we are given two vectors in same direction. One is 15 Newton, other one is 5 Newton. So what is the addition of these two vectors? What is the addition of these two vectors? That is 20 Newton to the direction of A to D. That is 20 Newton to the direction of A to D. Okay. So if I, when I am adding two vectors in same direction, I have to add the two. I have to add two magnitudes to get the magnitude of addition vector. Okay. Then the second application. The second application is vectors in opposite direction. Okay. Addition of vectors in opposite direction. So you can write the topic number 2, addition of vectors in opposite directions. Opposite direction. Addition of vectors in opposite direction. Okay. Suppose that and I have to add this vector to a vector which is in opposite direction to AB. So this is the starting point. So C to D, this is B. I have to add A and B, which are in opposite direction. Tell me, what should I do first? What is my first step? What is my first step? What are the points? What are the points that should be coincide? What are the points? Yes, B and C. Okay. Look at this. So what is the endpoint of first vector? What is the endpoint of first vector? This one. This is the endpoint of the first vector. So what is the starting point of second vector? Now the starting point is here. Okay, starting point is here. Not the closest one, okay? Not the closest one. The starting point is here. Okay. You can determine that thing from the arrowhead. From the arrowhead, no? From the arrowhead. So the starting point of this vector is C. So you have to coincide B and C first. B and C first. Suppose AB length is greater than CD length. Okay. Now A, B and C. If I coincide B and C, then this vector will be here. Okay. You can use different colors. Okay. If you have two pens, then use different colors. Then this is D. This is D. Then now this is the starting point. This is the end point. So what is the addition of A and B? A and B. The addition of A and B equal to AD vector. AD vector. That means this vector is equal to addition of A and B. Did you get my point, everyone? I need your response. So addition of AB is equal to AD vector. Another. I need response. Good. Others? Yes. Okay. Okay. Good. Look at this. I have to add AB plus CD. I have to add AB plus CD, puta. Then what did I do? What I have coincide B and C. Therefore, B and C. C becomes B, no? Now C became B. So I can replace C by B. So now this is equal. Now I have convert this thing to AB plus BD. ED. Because as I coincide B and C, I can use B instead of C. Okay. Then this is equal AB plus BD. AB plus BD equal to AD vector. AD vector. AD vector. Okay. Okay. Now I did this calculation using the principle of vector addition. Okay. If you are asked to find the addition of two vector, you should give two data. The first one is the magnitude of addition vector, magnitude of resultant vector. The second thing is the direction of resultant vector. Okay. There's a name, resultant vector, no? I will give that word. Okay. Normally, the resultant vector is the vector. Suppose the resultant of two vector is the vector that can replace the both vectors. That means the addition of two vectors is called as the resultant vector. The resultant vector of these two vectors. Okay. So AD is the resultant vector of AB and BD. Okay. So if you are asked to find the addition of two vectors, you should give two data, two points. What are those? You have to give the magnitude of that vector and you have to give the direction of that vector. So now I should calculate the magnitude as well as the direction. Magnitude of AD vector. Magnitude of AD vector. So AD vector is represented by AD line segment. This AD vector is represented by this AD line segment. Therefore, magnitude of AD vector should be equal to the length of AD, to the length of AD line segment. So this should be equal to the length of AD line segment. Okay. Okay. AD line segment. I can find the value of AD line segment by subtracting AB and BD. AB and BD. So AD is equal to the subtraction of AB minus BD. Look at this, AB minus BD. If you subtract BD from AD, you will find AD length. Okay. Then, so what is this value? AB. What is this value? AB length. So AB length is equal to the magnitude of A vector. to the magnitude of A vector. So AB length is equal to the magnitude of AB. And BD means CD, no? CD, no? So this length, BD length is equal to the magnitude of B, to the magnitude of B. So I can write this one. Magnitude of A vector minus magnitude of B vector. Magnitude of B vector. Then I can find the magnitude of AD vector. The magnitude of AD vector, I will write here, okay? Magnitude of AD vector is equal to the magnitude of A minus magnitude of B. Magnitude of B. Okay. Did you get my point? Everyone, I need a response. Did you get my point? Thank you. Others? Okay. Okay. Now you can write the topic, then draw this diagram. Then I will give some say small paragraph. Write the topic and draw this diagram. Don't write this one. Don't write anything here. Just draw this diagram. Okay. Right under this. Right under this. In this diagram, you can write this is the end point. This is the end point. End point. And this is the starting point. Write that too. When you are attending to the vector lesson, I think it is better to having a ruler, a pencil, some two color pens. I think it is better. Okay. You should have a ruler. And tomorrow there will be a basic maths class. Then we are going to discuss about trigonometry. Okay. Okay, right under this. Okay, right under this. We have to apply the principle of vector addition. We have to apply the principle of vector addition. The principle of vector addition to add those two vectors. Therefore, the endpoint of the first vector, must be coincide with the starting point of the second vector. In another paragraph, then we will have a starting point. And an endpoint. We can connect these 2 points. We can connect these 2 points to have the resultant vector, You can underline that thing, resultant vector. To have the resultant vector. Okay. Now you can write this thing, okay? After that, you can write this thing, and first you have to coincide B and C. and then you can find the magnitude of AD length, that is equal to the subtraction or difference between A and B magnitudes. Have you completed the writing? Shall I erase this thing? Okay, thank you. What about the others? Still writing? Okay. Okay. Now we have calculated the magnitude of the resultant vector. Now we should find the direction. So what is the direction? What is the direction? What is the direction? Can anyone tell me? What is the direction of the resultant vector? What is the direction? Yes, very good. Look at this. In here, yes, very good. In here, A to D. In here, the direction is A to D. A to D means it is equal to the direction of AB vector, which is the largest one. No? Therefore, the direction of the resultant vector is the direction of the large vector, larger vector. Then direction. Then you can write direction. Direction. Direction is equal. It is equal to the direction of larger vector. Okay. Okay. In previous paragraph, I asked you to underline the resultant vector, no? Okay. Then I will give the note for that one. Okay. Write a special note. Write a special note. That is resultant vector. Resultant vector. Resultant vector. Resultant vector. This is a special note. Okay. Write under this. Write under this. A resultant vector. A resultant vector. A resultant vector is the vector that is equal to the vector sum, that is equal to the vector sum of two vectors or vector system. A resultant vector is a vector that is equal to the vector sum of two vectors or vector system. Now we can Write some examples for this application, that is addition of two vectors which are in opposite directions. Look at these examples. The first one. Suppose you are given AB vector that is equal to 10 Newton here, and which is exerted on object, and there is another force from this side which is equal to 4 Newton. So what is the resultant force, or what is the resultant vector acting on this object? What is the resultant vector acting on this object? How to find the resultant vector? You should add those two vectors. No, add those two vectors. So when you are adding those two vectors, this is the vector which is opposite to this one. So the resultant is 6 Newton to the direction of AB, Okay, same thing we can do in vertical directions. Suppose this is 12 Newton. So if I add this thing to 16 Newton here, so what is the resultant vector? What is the resultant vector? Resultant vector. What is the resultant of vector of these two? Magnitude and direction. Go tell me quickly. Go. Yes, sir. 6 Newton. 12 and 16. 12 and 16. Yes. How to get the answer, Buta? How to get the answer? The only thing you have to do, just take the difference. Just take the difference, because those two are in opposite direction. So get just the difference. Just get the difference. Okay. Difference is, yes. Difference is 16 and 12. Difference is 4. Now you have calculated the magnitude. Okay. Then you have to determine the direction. Direction is the direction of the larger force, which is the direction of 16. Therefore, the resultant is 4 Newton towards the downward direction. Okay. Okay, write these two examples. Okay. Complete rather. Okay. Shall I erase this one? Okay. If you can give responses, it will be much appreciated. Okay, because I can understand you are in with me. Okay, otherwise you are in with me or not. Otherwise, I cannot understand whether you are focusing on this lesson or not. Okay, therefore, once I ask a question, please give me a response. Okay, it doesn't matter whether it is correct or not. It doesn't matter. I just need a response. Okay. Okay, Buddha. Okay. I need your attention again. I need your attention. The first thing. Now we have discussed, up to now we have discussed how to add two forces, so two vectors which are in same direction, and how to add two forces, two vectors which are in opposite direction. Those are two applications of vector addition theorem. The third application, I think this is the most difficult one. Addition of vectors which are in actually inclined vectors. So how to add inclined vectors? That is a third application. Okay, they write a topic. Addition of inclined vectors. Okay, listen very carefully. This is the most difficult one. Okay, because you have to have very good geometrical and trigonometric knowledge to solve these problems. Okay, I will explain this thing. Inclined vectors means there's an angle between these two vectors, okay, which is not equal to 0. If it is 0, then definitely those two vectors are parallel. Okay, those two vectors are parallel. That means either it will be in same direction or opposite directions. Okay, now the angle is not 0. That means it has an angle. Suppose you are given this kind of vectors. Suppose you are given this kind of vectors. AB plus CD. Okay. How to add those two? If I apply principle of vector addition, this is very easy, no? First you have to coincide B and C. Then you will have two free ends, which are A and D. You have to connect these two. That is only. Okay. First you have side B and C. First you have to coincide B and C. B and C. Then there will be two free ends. One is a starting point, other one is an end point. Okay. This is the point of A. This is the end point of A, Puta. End point. This is the starting point. Okay. If I apply vector addition theorem, I have to coincide the end point of the first vector with the starting point of the second vector. That's why I coincide B and C. Okay. Then there will be two free ends, which are A and D. A and D, sir. Well, A and D. Then you have to connect these two. You have to connect these two. Then you will have the resultant vector A and D. Resultant vector A and D. Okay. Normally we represents the resultant vector as R. Okay. R. A and D. Then what is the difficulty? Difficulty is finding the magnitude and direction. You can join these two vectors. That is an easy thing. But this is not the end. This is not the end. If you are asked to find the addition or summation of two vectors, you have to give the magnitude as well as the direction. So you have to find the magnitude. So magnitude of A plus B vector is equal to the length of AD. How to find length of AD? Tell me how to find. Can anyone give me a proposal? How to find length of AD? How to find that time? In here, I don't have any information to find the value of AD. Okay, so in some question, you are given some information. You are given some information to calculate AD. Okay, from that information, you have to calculate AD using your geometrical and trigonometric knowledge. Okay, therefore, trigonometry and geometry is very important here. Okay, so I can write AD vector is equal to AB plus BD. AB plus BD. AB plus. Look at this relationship. AB plus BD. Look at this one. The endpoint of first vector is equal to the starting point of second vector. Listen very carefully. Everyone, listen very carefully. Look at this. The endpoint of first vector is equal to the starting point of second vector. Once you coincide this thing, you should write in this manner. Okay. This is the endpoint. This is the endpoint. And this is the starting point. This is the endpoint of first vector, and this is the starting point of second vector. Both are same. Both are same means you have coincide these two. That is the meaning of that. Okay. Therefore, when you are adding two vectors, if you write that addition in an algebraical way, in algebraic notation, you have to write in this manner. Okay, AB plus BD, AB plus BD. The endpoint of the first vector should be equal to the starting point of the second vector. Then it will be cancelled out. And AD will remain. Okay. Okay. AB means vector A. Vector A plus BC means vector B. BC means vector B. Therefore, AD vector is equal. Therefore, AD vector is equal to the addition of vector A and vector B. Okay. Up to now, we can write only this, because I cannot determine, I cannot evaluate, I can find the value of AD because there's no any information. Okay, so that's why I said earlier, this is little bit hard question, because you should have very good geometrical and trigonometric knowledge. Okay, then write the topic and write under this. Okay, okay, we can use I will give the answer. We can use vector addition theorem to solve this question. To solve this question. As stated previously, the endpoint of the first vector, has to be coincide. With the starting point of the second vector. Then we can find the resultant vector. By connecting free ends. Okay, after writing, you can draw this image and write up to the end. No, we cannot use magnitude sign here, Stu, because the magnitude of AB and magnitude of BD is not equal to the AD. Okay, that's the problem. We cannot say AB plus BC maybe BD is equal AD. This is a triangle, so we cannot use magnitude sign here. Okay, That's why I said it is very difficult, no, not difficult, but relatively hard to find magnitude. So this is not the magnitude equation, okay? This is not the magnitude equation. This is just a vector equation, just a vector equation, vector addition. Okay, I will give the magnitude one. Once you write up to here, please give me a thumb. Okay. Shall I clear the board? Okay, thank you. Okay. Now we should find the magnitude of this vector, Buta. Okay. Now we should find the magnitude. Find the magnitude. Finding the magnitude of R. How to find the magnitude of R? In that case, we should have clear geometrical and trigonometric information. Okay. According to this information, we should calculate the length of AD. Length of AD. Suppose this example, this example, okay. Suppose here there is a displacement towards the north direction 30 meter. 30 meter. This is AD. And you have to add. And there is another displacement towards this direction, which is equal to 40 meter. CD. A, B, C, D. If you want to add these two, you can follow the same procedure. If you follow the same procedure, you will have this kind of triangle. You have to connect coincide B and C. You have to coincide B and C. Then this is 30. This is 40 meter. A, D. In here, it is very clear. This vector is headed to north, while this is headed to east. So the angle between these two vectors should be 90 degree. This should be 90 degree. It is very clear. So it is the information hidden in the given question. Okay. Then that resultant is AD. The resultant is AD. Okay. Now you can use your trigonometric knowledge to calculate the magnitude of R. How to calculate the magnitude of R here? How to calculate the magnitude of AD? Magnitude of R vector, magnitude of resultant vector is equal to the length of AD, length of AD. So magnitude of R means length of AD. So finding the magnitude of resultant force is finding the length of AD. So how to find length of AD? Yes, simple thing. You have to use Pythagoras theorem. Using Pythagoras theorem, you can find AD. Likewise, you will be given some information. Using that information, you have to find the length of AD. It is different from one question to one question. In here, you can use Pythagoras theorem. But another question, it is something different to Pythagoras theorem. Okay. Therefore, question to question, the information and the method will be changed. But you will be given some information. Using that information, you have to process that information using your geometrical and trigonometric knowledge. That is the only thing. Okay. Okay. Then put a star mark and write this one. Finding the magnitude of R. Finding the magnitude of R. Don't draw this thing. Just it is not a topic. Finding the magnitude of resultant force. Okay. Okay, right under that. Right under that. The magnitude of resultant force, the magnitude of R, the magnitude of R is equal to AD length. The magnitude of R is equal to the AD length. The AD length. Therefore, we have to calculate AD length. AD length. We have to calculate the AD length. To get the magnitude of resultant vector. To get the magnitude of resultant vector. To get the magnitude of resultant vector. write in another paragraph. As this is a triangle, we will be given relevant geometrical or trigonometric information. Relevant geometrical or trigonometric information to calculate the magnitude of R, to calculate the magnitude of R. Okay, after writing that one, you can write this, you can draw this example. This is example. So magnitude of R is equal to square root of 30 plus 40, that is equal 50 meter. Okay. Please stop writing. And look at the board. Everyone, stop writing and look at the board again. Now you have calculate the magnitude. How to find the direction? In the previous cases, we are actually it is very easy because the direction is same directions as the given vectors. Okay, but in here the direction is different than the given vectors. So how to find the direction? In that case, we have to use our trigonometric knowledge. So suppose this angle is theta. That is assumption. We can assume this angle is theta. Theta is the angle between the vertical and the resultant vector. Theta is the angle between the vertical and the resultant vector. You should state that thing. Okay, either in word or in the figure. Actually, it is sufficient. If you can draw this in your figure, it will be sufficient. Otherwise, you can state that thing in word. Theta is the angle between the vertical and the resultant vector. Then, how to find theta? That is very easy. You can use your trigonometric knowledge. You got this? According to this main triangle, tan theta is equal to 40 over 30. 40 over 30. According to this triangle, this is direction. Okay. Tan theta is equal 40 over 30. 40 over 30. 40 over 30 means 4 over 3 puta. 4 over 3. Okay. Then the direction is you should subject theta. You should subject theta, then give the value of theta. Give the value of theta because you have stated what is theta. You have stated, we have clearly stated what is theta. Theta is the angle between the vertical and the reaction force, reaction vector, resultant vector. You have given that thing. You have stated that thing. Then you have to evaluate or you have to calculate the value of theta. It is very easy. You can calculate tan theta value from this value. You can subject theta. Theta is tan inverse 4 over 3. 4 over 3. This is enough. This is enough. You can further simplify this thing using your logbooks. Okay, that is not needed. That is not needed. In A levels, up to this level is sufficient. Okay. Then first you have to write up to this. Then this is the way how to find the direction. Find the magnitude. This is direction. Once you complete writing, please give me a thumb. Thank you. Others? Okay. Others? Okay. You have to write up to this, okay? Up to this level. First, the magnitude, then the direction. Okay. No, there is no definition of direction. There's no definition of direction. You have to you have to define that thing. That means direction. When you are saying direction, actually the direction should be some particular way, no? Therefore, that thing should be defined by yourself. That is, suppose you have to find a direction. Then, if you want to find a direction, actually it is better to define an angle between vertical or horizontal. If you define an angle between vertical or horizontal, as it is a straight line, then your direction is very clear, no? Because yes, you can take any angle. You can take any angle, either this one, and this one also equal, no? Okay, you can take either vertical or horizontal angles. You can take the angle between the vector and the vertical or horizontal, because we know the exact direction of vertical or horizontal. We know that direction. Okay, the direction of vertical line and direction of horizontal line. Everyone know the direction of vertical and direction of horizontal lines. So if you define the direction of this vector is inclined to the vertical by theta angle, or the direction of this vector is inclined with the vertical, with the horizontal by alpha or something, then the direction of vector, we can get the direction of vector. That is a way of getting direction of vector. Did you get my point? Did you get my point? Okay, because vertical direction and horizontal directions are defined. It is known. Okay, I think that thing you should stare at that thing. Very good question. Okay, right under this. How to get the direction of R? How to get the direction of R? Small, not a topic. Small. Put a star mark and write how to get the direction of R. How to get the direction of R. Right under that thing. Right under that thing. We know the direction of the horizontal line, so the vertical line and the horizontal line. We know the direction of, we know the exact direction. Okay, we know the exact direction of the vertical and horizontal lines. Vertical and horizontal lines. assume the resultant vector creates a certain angle with the horizontal and the vertical. If we can find this angle, we will know the exact direction of R. We will know the exact direction of R. Okay. This is the first method. This is the method 1. Okay, this is the method 1. Method 2. Okay, I forgot. You can draw this one. Okay. This thing you have to theta. This is alpha. You have to find either theta or alpha. X, Y. So you have to find either alpha or theta. මේක ඕනේ නැහැ. method 2 එක ඕනේ නැහැ. ඒක මේ බර වැඩි ඔයගොල්ලන්ට. ඒක මැත්ස් කරන කට්ටිය උනා ඒකට. එතන මැත්ස් බයෝ දෙකොල්ලම ඉන්නවනේ. ඒක දුන්නොත් එහෙම පැටලෙනවා. Okay. This is the one. මම කියන්න method 2 එක මොකක්ද කියලා මම කියන්න. Method 2 is actually if we know the exact direction of a vector. If you know the exact direction of because when we are adding two vectors, actually we know the direction of two vectors. No, we know the exact direction of two vectors. Okay, so if we can find the angle between the resultant vector and between and the, that's mean, suppose we are given this kind of vector system. Suppose my first vector is from here and second vector is from here, then this is my resultant vector. Okay, we know the exact direction of the given vectors. We know the exact direction of the given vectors. Okay, so if we can find the angle between this vector and the resultant vector, this angle can also consider the direction of R, because this direction is known already. This is known already. Okay, මේකට යන්න එපා. මේකට පොඩ්ඩක් මේක mathematical part එක පොඩ්ඩක් වැඩි අවශ්‍ය නැහැ. ඒක නිසා just take the direction between the vertical and the horizontal. Vertical or with the horizontal. That is very easy. Okay. Do you have any questions up to now? Do you have any questions? Do you get all the things? Did you get all the things? Hey, not. Everyone, I need your response. Golu wage inne epa appa. Did you get my points? Yes, thank you. Others? Thank you. Others? Thank you. Okay. Then we can summarize. What we have discussed up to now. Okay. Regarding the vector addition. In vector addition, we have discussed three applications. First one is vectors in same direction. The second one is vectors in opposite direction. Third one is vectors which are inclined to each other. Okay. The first application is in same direction. Second thing is third one is inclined vectors. Okay. Vectors in same direction. Okay. How to find the magnitude? Magnitude of R. Magnitude of R is equal to the to the addition of magnitudes of two vectors, no? Addition of magnitude of two vectors. So that is the magnitude. So direction, what is the direction? It is equal to the direction of one vector. It is equal to the direction of a vector. The second thing, vectors in opposite direction. So magnitude of resultant force. Magnitude of resultant force is equal to the difference between A and B. No, difference between magnitude A and magnitude of B. Magnitude of A and magnitude of B. The direction. Direction is equal to the direction of larger vector. It is equal to the direction of larger vector. Larger vector. Okay. Then the third application. Incline vectors. Incline vectors. So how to find the magnitude of incline vector? Magnitude of incline vector. How to find? In this case, we have to use some geometrical knowledge, geometrical or trigonometric knowledge. We have to apply geometric knowledge. Have to apply geometrical or trick knowledge. Direction. How to find direction? Direction. We can just define as the angle between vertical or horizontal. Angle between vertical or horizontal. Okay, so this is the summary. This is the summary of vector addition. Vector addition. We have discussed two vectors in same direction, two vectors in opposite direction, and inclined vectors. Okay. Okay. Write this chart. Okay. Suppose okay. Look at this. You can copy this chart. I'm answering the question of history. Okay. Look at this issue. How to say about the direction? How to define the direction? Suppose you are going somewhere. Suppose you are going somewhere. Look at this. Suppose this is a large stadium or large ground. Large ground. Suppose you are in here. You are in here. First you are in. You are at the point A. You are at the point. You are at the point A. Okay. Yes. Yes, very good. Suppose you are at point A and you are going somewhere. You are going somewhere. Yes. That's why now I am explaining that in hit. Okay. First, you are at this point. First, you are at this point, and you are going somewhere in this ground. Okay. Suppose you are going in this direction. You are going in this direction. Okay. So, how to define the direction? How to define the direction? How to define the direction? First, you are at point A. You are at point A, and now you are going A to B. No, suppose this one from A to B. A to B. No. There's no any point. Okay, there's no any point. Suppose you are going here. So, how to define? Where are you going? How to define that thing? Is that north? Is that east? Can you give me a definition? How to define that thing? In that case, you should define the direction with respect to this point, and with respect to a non-direction. Suppose you know where's the north is. You know where's north is. Okay. I think that thing you have done in your orders, no? The moving direction with respect to north and with respect to south, no? මම හිතන්නේ කරලා තියෙන මට මතක විදිහට තිබ්බා දිගාංශයද මොකද මන් දන්නේ කියලා එහෙම තිබ්බේ මට මතක නැහැ. හරිද? මේ මම හිතන්නේ ඔලොස් වල තිබ්බා. Okay? Anyway, suppose if you want to define the direction of point A, if you want to define the direction of point A, you should know two things. One thing is this point, your starting point, and a non-direction. Suppose you know the direction. You know the direction of north. Suppose it is in this. Suppose it is in this way. This is the direction of north. Then you can say you are moving theta angle. You are moving from point A, and theta angle from north to east. From north to east, because this is east, no? Theta angle from north to east. No? You are moving from point A to the direction from theta angle from north to east. Okay, that is how you define the direction of moving. Okay, you have to have exact point and non-direction. Otherwise, you cannot define a direction. Okay. Did you get my point? The first thing, you have to have a starting point of a particular location. Then you should. Okay. Definitely, you have to have non-direction. You have to have non-direction. In here, your non-direction is vertical or horizontal. That is your non-direction. That are your non-direction. Okay. හරිද? Shall I clear the board? Thank you. Others? Is she writing? Okay. Others? Okay. Let's do some examples. Okay. First one. I Newton AB. There are 8 questions. First, may write the questions, then you can answer. Sorry, you can give the answers. Sorry, first write the questions. CD 20 Newton. The second thing 20 Newton 50. 20 Newton plus 50 Newton. Third one 60 80. 60 meter 80 meter CD. Fourth one 30 meter AB plus 60 degree CD. Fifth one AB 40 root 3 30 degree. Thirty degree. This is 80. Sixth one. ABCD 60 Newton each. One pound. $45 degree. 40 Newton. Okay. First, Write all the questions, then give the answers. First do up to question number 4. Up to question number 4. Okay. I have to discuss question number 4 first. Then you can go 5, 6, and 7 after that. Okay. First, just do the questions up to question number 4, including question number 4. Okay. Here, this should be 60 meter. Okay. CD should be 60 meter. 5, 20, 20, 15, 60, 80, 30, 60, 40 root 3, 80, 60 Newton, 60 Newton, 40 Newton, 20 Newton root 3. Okay. Give me answers in your chat box. Okay. What about first one? First one. What is the answer? Magnitude. Magnitude. 5 times 5 and 20. 5 and 20. Both are in same direction. Both are in same direction. So magnitude is equal to 25. 25 and direction is A to D. That means towards the right hand direction. So this is equal to 25 Newton towards this direction. Okay. The second thing, what is the answer? Second thing, look at this. 20 Newton in here and 50 Newton in here. That means those two vectors are in opposite direction. So how to add, or how to get the resultant force? The resultant force, the magnitude is equal to the difference between those two forces. That means 20 minus 15. 20 minus 15 means Newton, 5 Newton. The direction is direction of the larger vector. The direction of larger vector is 20 Newton. So direction is towards the right hand side. Newton direction. The third one. Those are inclined vectors. So if I add these two here, 60 Newton from A to B, then I have to coincide B and C here. So if I coincide B and C, there should be 80 Newton here to D. So the resultant force should be directed from A to D, from A to D, the resultant. Okay. 60 Newton means it is vertical force, vertical vector, and 80 Newton, 80 meter is horizontal vector. So angle between them is 90 degree. So ABC is a right angle triangle. AB is a right angle triangle. So how to find AD? How to find AD? Magnitude of R. Magnitude of R is equal to the square of this one plus the square of this one the square root of square of 60 plus square of 80. So 80, 60, that means 100. Okay. Therefore, magnitude of R is 100. You have to define the direction, Puta, here. You have to define the direction. You can take this angle or this angle. In here, it is easy to take this angle. Then tan theta direction. This is sufficient, okay? If you draw this image, and mention this theta angle here, that is sufficient. Or otherwise, you can state that in word, okay? Theta is the angle between the vertical and the direction of R. Then I can find the value of tan theta. Value of tan theta is equal to the opposite side over adjacent side. That means 80 over 60. 80 over 60 means 4 over 3. 4 over 3. 80 over 60. That means 4 over 3. Then you can subject theta. If you subject theta, it is equal tan inverse 4 over 3. Tan inverse 4 over 3. Okay. That is up to 4. If you have anything to write up to this level, please write that thing. Note down. Okay. What about fourth one? Have done fourth one. Okay, everyone, look at the board. Board is there. Everyone. Okay. The fourth one. You have to write. You have to draw this thing. This is my first vector. It is equal to 30 Newton, 30 meter from A to B. So what should be the first step? You have to coincide B and C. B is the end point, C is the starting point. I should coincide B and C. If I coincide B and C, here 60 meter. This is the vector. So my resultant vector should be A to D. This is the resultant vector. This angle is given, it is 60. It is equal to 60. Okay. It is equal to 60. 60 degree. Okay. Now, how to find AD length? Common AD length. How to find AD length? in here, I will do a small construction. What is that? I will draw a perpendicular from D to AB line. I will draw a perpendicular from D to AB line. Suppose this point is M. Then D to vertical, horizontal, horizontal. I will construct a perpendicular from D to AB line. Look at this. You know this angle. And now there are two right angle triangles. What are those? One is MDB. Other one is AMD. AMD is a right angle triangle. So you can use Pythagoras theorem, because actually if now AD is a hypotenuse of a right angle triangle. So you can use the Pythagoras theorem to find AD. But if you want to use Pythagoras theorem, you should know the length of other two sides. What are the length of other two sides? Suppose if you want to find the length of AD, you should apply Pythagoras theorem to ADM triangle. ADM triangle. But you don't know the length of MD. You don't know. And you don't know the length of AB. AM. You don't know AM. But you know the length of AB. This one you know. This one you know. And this side, BC is not. So how to find BM, MD and BM? How to find that thing? How to find that thing? How to find BM? Yes, very good, very good. In that case, you can use your trigonometric knowledge, because now look at this small right angle triangle. Look at this small one. Look at this small one. In this small right angle triangle, you are given the angle, this angle, and the hypotenuse. There are two things you already know. No, hypotenuse and this angle. So if you want to find this BM value means it is the adjacent side. It is the adjacent side to 60-degree angle. It is the adjacent side. If you want to find adjacent side, there are two known factors. What are those? The angle and the hypotenuse. So what is the trigonometric ratio to find adjacent side? It is cos theta, no, cos theta, cos 60. So if you consider BMD triangle, look at this. You can write the expression, to cos 60. Cos 60 should be equal to the adjacent side over the hypotenuse. Adjacent side puta, it is equal to BM. The hypotenuse is given, it is equal to 60. You know the value of cos 60, it is equal to half. It is equal to half. So half is equal BM over 60. So BM is equal to 60 degree, 30 meters. 30 meters. Then you should find the value of MD. How to find value of MD? How to find value of MD? You have to use sine 60. You know, in here sine 60. Sine 60 is equal to the opposite side over hypotenuse. Opposite side means MD over hypotenuse means 60. 60. Sine 60 is equal to root 3 over 2 is equal MD over 60. That means MD is equal 60 times root 3 over 2 means 30 root 3. 30 root 3 meter. Now you know the length of AMD triangle. AMD triangle. So if you draw the length of AMD triangle, this is A, this is M, this is D. So AM is equal to 30 plus 30. 30 plus 30 means 60. This is the 60 meters. MD is equal 30 root 3. You have to find AD. How to find AD? You have to apply Pythagoras theorem to AMD triangle. So Pythagoras to AMD triangle. Pythagoras to AMD triangle. So AD squared or the magnitude of resultant vector is equal to the square root of this one. That means 60 squared plus square of this one. 30 times root 3 squared. 30 times root 3 squared. So this is equal to, look at this. This is equal to 30 in look at this. You can simplify this one without expanding all the things. Okay, look at this. 60 means 30 times 2. 30 times 2. 30 times 2. So I can write this one 30 times 2 squared plus 30 squared plus 3, no? This is 30 squared. Root 3 squared means 3. Look at this. If I expand this one, that this is equal to 30 squared into 4 square of 2. 30 squared into square of 2. That means 4. So I can take 30 squared out from this square root. 30 squared, because here there's 30 squared, here there's 30 squared, and here also there's a 30 squared, square of 30, square of 30. So I can take it out from the square root. So if I take a square from a square root, it becomes that particular number, 30. So this is equal to 30 into 2 square. 2 square means 4 plus 3. 4 plus 3. Therefore, magnitude of R is equal 30 into root 7 meter. 30 into root 7 meter. Did you get my calculation? Did you get my calculation, if, especially in here? Everyone, I need your response. නැද්ද? තේරුණේ නැද්ද? Others? Others? No? History? Yes, me? I need your response. Others? Okay. If you the first thing you have to understand, if you are given this kind of vector diagram, then you have to construct some construction. Okay, you have to do some construction. Okay, especially I think it is easy if you can follow Pythagoras theorem. Okay, that is not applicable for all the questions, but think using Pythagoras theorem first, whether I can apply the Pythagoras theorem or not. If you want to apply Pythagoras theorem, there should be right angle triangles. Then you should construct some perpendiculars to some relevant sides, to some relevant sides. Okay, therefore, if you are going with Pythagoras theorem, there should be definitely right angle triangles. Then you have to construct them. Okay, that is a way of thinking. Okay, one way of thinking. That is not the only way. Okay, so if it is not matching with the given question, then you have to find another way. Okay, that is the first thing you have to understand in this question. The second thing is this calculation. The second thing is how I find these two values. How I find these two values using this right angle triangle. I think we have done this kind of question. How to find unknown lengths of right angle triangles. Okay, we have done this thing. So I can write some expression for given angle, either cos or tan or sine. Okay, using that expressions you can evaluate any angle. Okay, for that you have to have an angle, a non-angle, and a non sides of a triangle. Okay, then the last one, how I did the calculation. Actually, if you proficient with this calculation, you can just skip this step 2. Okay, you can skip this step 2. You have to have that much of proficiency. Okay, you have to improve your mathematical calculations ability to skip these steps 2. Here, this is 30 into 2, 30 into 2. 30 into 2 means 30 squared into 4. Here, 30 squared into 3. So you can take 30 squared from the square root. If you take it out, it becomes 30 because it is under the square root. No, it becomes 30. So if I take it out, the remaining is 4 here. The remaining is 3 here. Both should be add. So if I add these two, it becomes root 3. So answer is 30 root 3. It is enough. Okay. You don't want to find the value of root 7. Okay. Then the angle. This is the angle. This is the angle. So tan theta is equal 30 root 3 over 60. 30 root 3 over 60. So it is root 3 over 2 tan theta. Okay, this is tan theta, not sine or cos. Okay. So I don't know the value of root 3 over 2 of tan theta. So you can just subject theta, tan inverse root 3 over 2. Tan inverse root 3 over 2. சரியா? Okay. Then do the question number 5. Question number 5. Do the question number 5 and send me the answers. Question number 5. Forty root 3 AB then 80. You have to do same procedure here. The angle is different. This is 30 now. So what is the value of R and this angle? R and theta. You have to find R and theta. You have to find R and theta. Do it and send the answers to me. Question number 5, 6, and 7. Now you can use the same method. Okay. Where is to right hand? Third one no, fifth one no, sixth one. You're asking about? Fifth one. Why? There's no right angle. You have to construct. You have to construct. Okay. You have to construct. You have to draw a perpendicular from D to M. This is the right angle. Okay. This is a construction. It is a construction, Puta. Okay. Actually, the actual figure is here. This one. This is the actual figure. This is the actual triangle. No, when you are adding AB and CD, this is the actual triangle. You cannot do anything using this triangle. That's why you have to extend AB from B to M, and you have to construct the perpendicular line from D to M. This is a construction. Okay, you are free to do any construction. No, actually, this is a construction, Puta. This is a construction. We can do any construction. You can do any construction to solve this question. Okay. Therefore, actually, what is my assumption? What is my assumption? Look at this. What is my assumption? Actually, this is the actual triangle. When you are adding AB and BD, when you are adding AB and BD, this is your output. No, you have to find the length of AD. You have to find the length of AD. Okay. In this case, you know this is 80 and this angle is 30. Okay. This is the only thing you know to find this value. Okay. Oh, yes, you have to step. Okay. Okay, Puta. Now, actually, now you haven't any other information. No, you haven't any other information, Puta. Those are your information. Using this information, you have to find AD. You have to find AD, the length of AD. The length of AD. You cannot find length of AD without using any geometrical or trigonometric relationship. You have to build a trigonometric or geometrical relationship. In that case, in our previous question, I have used Pythagoras theorem. To use a Pythagoras theorem, you should have right angle triangles. Then you should actually there is no any right angle triangle. No. If there is no right angle triangle, you have to construct them. Okay, you have to construct them. That's why I extend AB little bit further. I have extended AB little bit further to the upside. Okay. This is the AB line. Then this is the AB line. Then I have drew a perpendicular from D to AB line. This is a construction. You are free to do any construction. It is a construction. Okay. The reason why I did the thing, because if I draw a perpendicular line, then I will have two right angle triangles. What are those? Suppose this is M, BMD and ADM. Those are the two right angle triangles according to this construction. Okay. So now it is very clear AD is a hypotenuse of one of these right angle triangle. Okay. AD is a hypotenuse. So you can easily find AD if you know the other two sides. Okay. What are the other two sides? AM and MD. AM and MD. Then you have to find the value of MD and AM. Okay. To find MD and AM, you have to have the value of MD and BM. Okay. To find MB and MD, you have to use this small right angle triangle. Did you get my point? Yes, you? Okay. So this is a construction. It is not a given data. It is not a given data. It is a construction. You are free to do any construction. Okay. But it should be relevant to the answer. Okay. Okay. Any construction mean it should be relevant to the answer. You cannot use tan, Uta. You cannot use tan. No, actually, look at this. This is BMD triangle. This is BMD triangle. In this triangle, what are the known things? What are the known things? In here, what are the known things? You know the length of BD. You know the length of BD. This is 80. You know this length. This is 80. Okay. Then what is another thing? Another known thing? Other known thing? That is 30. Those are the only things you know. Okay. From these data, you have to evaluate MB and MD. BM and MD. Okay. Suppose you have to evaluate this thing. If you want to find this value, you should decide what are your known factors, what are your known things. Your known thing is this angle and this one. This one is hypotenuse. This angle is 30. So what is this length? MB length, MB side. What is the right side? Yes. This is the adjacent side with respect to this angle. Do you understand, Buddha? This is the adjacent side with respect to this angle. So you have to decide what are the side with respect to known angle. Okay. With respect to this angle, this is the adjacent side and this is the opposite side. This is the adjacent side and this is the opposite side. So if you want to find adjacent side, then look at what is the known factors? What you are known? The hypotenuse and this angle. So hypotenuse, adjacent side and angle. So what is the trigonometric ratios that combines these three factors? It is cos theta, no? It is cos theta, no? Cos 30 combines adjacent side and this angle and the hypotenuse. Okay? That is how I decide. That is the way of deciding the appropriate trigonometric ratio to find the length. Okay? If it is a hypotenuse, it is a non-value, it is a non-factor, its non-factor is hypotenuse, then there won't be tan theta. No. Tan theta comes with hypotenuse, comes with adjacent side and opposite side. So if the non side is a hypotenuse, then actually tan theta won't be there. So it should be either sin theta or cos theta. So if you want to find adjacent side with respect to hypotenuse and another angle, then you should use cos theta. If you want to find opposite side with respect to given angle and the hypotenuse, you should use sin theta. Okay? That is a way of deciding. Look at this. When you are applying, listen everyone. When you are applying Pythagoras theorem, or if you want to find some angle or sides, please mention the relevant triangle. Please mention the relevant triangle. Then your possibility of getting a wrong value will be reduced. Please mention the triangle first. Okay. Suppose if you want to find MB and MD, then mention the triangle. It is a must. Okay. BMD triangle. Using BMD triangle. Then everyone know what did you do here. Okay. Everyone know. You have used this triangle. Okay. That this should be stated. That is a must. Okay. BMD triangle, I can write sine theta. Sine 30 is equal MD over 80 Newton. 80. Therefore, MD is equal 80 over sine theta means half. Sine 30 means half. That means 40 is 40. Then you have to find BM. So how to find BM? You have to use cos theta, cos 30. Cos 30. Still you are using this triangle. Okay. Still you are using this triangle. That's why you have to write this under this triangle. Okay. You have to write this under this triangle. Then everyone know you are using this triangle to derive these values. Cos theta is adjacent side BM over hypotenuse 80. Okay. Cos theta is equal root 3 over 2. So root 3 over 2 into 80 is equal BM. So BM is equal 40 times root 3 Newton. 40 times root 3 Newton. Then now you have calculated every length. Then you can use AMD triangle. AMD triangle. AMD triangle. Look at this AMD triangle. AMD. AM value means AB plus BM. AB plus BM. AB is 40 root 3. BM also 40 root 3. So 40 root 3 means 80 root 3. 80 root 3. Again, MD is equal to 40. This is equal to 40. So I can write, this is my R. So magnitude of resultant vector is equal to square of this one and square of this one. Square of this one, 80 root 3 square plus 40 square. Look at this calculation. 80 means 40 into 2. 40 into 2. So I can write it as 40 into 2 times root 3 entire square plus 40 square. Look at this. Square 40 is there. Square 40 is there. So square 40 is a common factor. So you can take it out. If you take it out, it will be 40. It will be 40. So 40 is equal. What are the remainings? What are the remainings? What are the remainings? 40 remains. If I take 40 out, here 2 times root 3. 2 times root 3 is square. 2 times root 3 square means square of 2 and square of root 3. Square of 2 means 4. Square of root square of 3 means 2 means 4. Square of root 3 means 3. Plus, if you take 40 squared out, it will become 1. 1. So my answer is here 12. 12 plus 1 means 13. So my answer is 40 times root 13. Newton. Okay. Then you have to find the angle. You have to find the angle. How to find angle? Then again, you should state the triangle you are going to use to find this angle. State the triangle, Puta. That is a must. Triangle AMD. Using AMD triangle. Using AMD triangle, I can write either tan or either sine or either cos, anything, because all the lengths are known. Okay, I can use anything. Suppose I want to use tan or sine or anything. Sine theta. Sine theta is equal to opposite side. What is the opposite side? What is the opposite side to this angle? It is MD, you know, because I am using AMD triangle. I am using AMD triangle because when you write in a trigonometric ratio, it should be a right angle triangle. Otherwise, you cannot write any trigonometric ratio. Okay, it should be a right angle triangle. Okay, you cannot use this triangle. It should be a right angle triangle. So my right angle triangle is AMD. Okay, so sine theta is opposite side MD over hypotenuse AD. MD means 40. Yes, 40. This is 40 to 30. Put 40 to 40 will be cancelled out. So sine theta is equal 1 over root 13. So theta is equal sine inverse 1 over root 13. 1 over root 13. Okay. Everyone, I need your response. Yes. This is the last question, Puta. This is the last question. Right? You have to do other 2 questions as a homework and may send that to me. Send your answers to me. Okay. So this is the last question. Other 2 questions you should do that home. Then send that to me. Okay. Everyone, did you get my point? Yes, thank you. Steve. Okay. Do you have any questions regarding today's lesson? Do you have any questions regarding today's lesson? Other two questions you have to do at your home as a homework and send that to me. Send your answers to me, okay? Then I will check. The methods, maybe you have to change your methods, but you have to follow the same way, okay? Okay. Do you have any questions regarding today's lessons? Okay. Tomorrow we are going to discuss trigonometry. In trigonometrics, actually you are given two tutes. First tute and second tute. Second tute is a small tute. But in this tute, there are some questions regarding finding lengths of triangle. If you are given a trigonometric ratio, using that ratio, how to find the length of triangles, length of some sides. Okay, length of some sides. Okay. In as I remember, in tube number two, there were that kind of question. Okay, please go through that. Then you can actually, then you will have enough experience to find these kind of values. Okay. Okay. Then we can complete today's class. Do you have any question? Please let me know now. Okay, Buta. Then we can complete this thing. Everyone, have a nice day and good afternoon. Okay. Thank you.